Alright, this is the lesson on hyperbolas in case you need some extra help. Hyperbola is part of a conic, and it's when you slice a conic parallel with its vertical axis, and you get two U-shaped graphs. Okay, and this is what a hyperbola looks like on its side. We call this a horizontal transverse axis. The transverse axis is the distance between the two vertices, and the vertices is right here, and that's the transverse axis. So this is a horizontal transverse axis. In order to talk about hyperbola, we are going to take our ellipse and we're going to put a box around that ellipse so that the vertices touch the sides of the box and also the co-vertices. That means the width of the box is the major axis and the height of the box is the minor axis. Or if it was, oblong vertically, then it would just be switched. But it's still a box around your ellipse. And then if you draw two diagonal lines through that box, cutting through the corners, you basically have your boundaries for your hyperbola. These are the asymptotes. That means they can never touch your graph. So we're going to put the vertices in the same place as my ellipse, except we're going to flip it inside out. So we're going to flip that ellipse inside out, and using my asymptotes, or my diagonals to the box, as my guidelines for drawing them. This graph is a little off because the hyperbola can never touch the asymptotes. Alright, the transverse axis on this case is horizontal because the two vertices are horizontal towards each other. There's a horizontal transverse axis, and then there's also a vertical transverse axis. Okay, and these are the asymptotes, and you notice it doesn't have to be longer in any direction, but the transverse axis has to touch the two vertices. So just like in our ellipse, our A is going to be the horizontal distance from the center to the vertices, and the B is the vertical distance from the center up to the box, or the box in either the direction. A is the horizontal, B is the vertical. And this is my equation for this particular hyperbola, with the center being at the origin. Just remember that there's going to be minus h and minus k as in our ellipse, except the only difference is it's a subtraction in the middle. Notice that our C now is inside of our curve, so it's actually beyond A. So it went from the inside of my box, the focus point, to outside of my box. So now C is longest distance, and we can actually use the Pythagorean theorem to find C. A squared plus B squared is equals C squared. In the ellipse, it's A or B squared minus the other one to get C. So it's kind of a little bit different. Okay, those are focus points. My transverse axis, and the one that does, the axis that does not touch the vertices, that's the conjugate axis. So this is my formula for the horizontal transverse axis. Notice that x is positive, and for the vertical one, y is positive. And there's a minus in between. If x is positive, y is negative on the horizontal, and vertical, y is positive and x is negative. And also notice that k and b go with the y, and h and a go with the x, no matter where the x is. Always has to equal 0, like my ellipse. This is the equation for the asymptote. The slope is going to be b over a. Okay, this is just the point slope form with the k moved to the other side. So it's y minus k is equal to the slope x minus h. And it's plus or minus because you have two asymptotes, one with a positive slope and one with a negative slope. Alright, so there's two asymptotes. There's your box in the middle, and notice that the slope is going to be rise over run, so it's going to be up B and over A. And this one goes in the positive direction, and this one goes in the negative direction. All right, this is when the equation of the hyperbola or the asymptotes are at the origin. If you take it off the origin, then you're going to have to use the h and k in the formula too. You have to move the x over and the y over from the center. All right. Okay, now let's try this example here. Write the standard form for a hyperbola given the foci are at -1, 2, and 5, 2, and the vertices at 0, 2, and 4, 2. Now you can use either pair of these to find the center. The center between -1 and 5, okay, should be 2, because if you add -1 plus 5, that's 4. 4 divided by 2 is 2. If you take the average between 2 and 2, that's also 2. 2 plus 2 is 4, divided by 2 is also 2. So you look at it on the graph. I usually don't do it with the graph. I just take the average of the points. But if you look at it on the graph, it's obvious that the center is 2, 2, because you're averaging -1 and 5. That's here. And then the 2 and the 2 don't move, so that has to be 2 right here. You can also do it with these 2 points and it comes out exactly the same, right? Okay, so you can also find the middle between the 2 vertices, and that will be also 2, 2. So I know my center is at 2, 2. That means h and k are 2. All right, we know that the distance for A is from the center to the vertices, so that's going to be 2. And we know that C is going to be 3 because that's from the center to my focus point. So that's 3. Now in order to find B, like I said earlier, is the Pythagorean theorem. So a squared plus b squared is equal to c squared. Moving the a to the other side, I get c squared minus a squared is equal to b squared. Plugging my numbers in, I get 9 minus 4 is 5. And that means that b squared is 5. Okay, so since we have b squared, we really don't have to worry about taking the square root, because in my formula it's b squared. Putting the h and k, a and b in all of this, we get a final answer of x minus 2 squared over 4 minus y minus 2 squared over 5. If you're looking for the focus the focus point, given this, you will have to take the square root, right? So b is just the square root of 5, or square root of this right here. Okay, so drawing my hyperbola, I'm going to go out 2.2 from the center, up 2.2 down, going 2 on each side, drawing my box, drawing my asymptotes, starting at the vertex, sweep it out in both directions, never touching the asymptotes. That's how I draw my hyperbola. Okay, let's talk about the eccentricity. Notice that the A on an ellipse is the distance from the center to the focus, from the center to the vertices. And then on this one is from the center to the vertices. And then C, C is on the inside of my ellipse, and C is also on the inside of my hyperbola, which makes C a longer distance than A. So the eccentricity is going to be E is equal to C over A. For an ellipse, that has to be between 0 and 1. But then on a hyperbola, that has to be greater than 1, because notice that C is larger than A, so that's going to be more than 1. Okay, so if you know the eccentricity is more than 1, you're talking about a hyperbola, and if it's between 0 and 1, it's an ellipse. Okay, solving for C, this is C squared is equal to A squared minus B squared, and on this one, this is the one that looks like the Pythagorean theorem, A squared plus B squared is equal to C squared. Alright, here's a nice easy one, graphing this. We know that the center is at 0, 0, and then we know that A is 3 and B is 2, and notice that X is positive, so it's going to be a horizontal transverse axis. That means it opens to the left and right. Opens with the X. If the Y was positive, then it opens with a Y. Okay, so I draw my box, draw my vertices, draw my asymptotes, and then sweep that out in both directions. And if you're putting the focus points, you have to use the Pythagorean theorem, and you're going to get 3.6. So 3.6 out from the center on both directions. That's going to give you your focus points. And my eccentricity is the square root of 13 over 3, or 1.2 approximately. And then finally drawing that out like that. Okay, let's move it off the center. And then first we find our center, which is -2, 4. And we know that it's a vertical transverse axis because the y is positive. And -2, 4 is here. And then my a is 3. And b is the square root of 16, which is 4. And then draw my box, draw my asymptotes, put in my vertices. Okay, my vertices is going to be at -2, 8, and -2, 0. Take the h, comma, k plus and minus b, right? So now my focus points, we have to find C. C is equal to 5. This is a 3, 4, 5 triangle. And then we can go 5 up and 5 down. So 5 up and 5 down from 4 is 9 and -1. Okay, and then just finding the eccentricity, C over B this time because it's going vertically, and then sweeping it out. That's my hyperbola. One more. May want to grab a sheet of graph paper and do this first and then come back and check. Alright, hope that you try that. So I'm going to start, and x is positive, so I know it's horizontal, opens towards the x axis on both directions. The center is at 1, -2. Okay, and then a is 4, b is 5. Putting my vertices in, putting my asymptotes in, and then c is the square root of 4 squared plus 5 squared, which is about 6.4. So I go 6.4 out in both directions from the center. The eccentricity is the square root of 41 over 4, which is about 1.6. And then just sweeping out my hyperbola. Alright. Here's one, practicing completing a square. You definitely should stop this because you should have had quite a bit of practice by now. You should be able to complete this one. So, okay, I'm going to do this now. Okay, I'm going to group my x and y terms together, and then I have to factor out the coefficient. Notice on the y is a -4. You can't complete the square with a negative square term, so make sure you factor that out also. So I'm going to factor out a -4 right here. Okay, which makes this a +4 right here. And when I factor out a 5, I get 8. Half of 8 squared is 16. Half of 4 squared is 4. Put that on the other side. Make sure you remember that it's 5 times 16 is 80. And -4 times 4 is -16. Put that on the other side. And then just simplifying that, you get x minus 4 squared. Y plus 2 squared is equal to 100. Make this equal to 1, divide everything by 100, and we get this after we reduce. So there's my equation. I know that this is going to be a horizontal transverse axis, and a is the square root of 20, and b is 5, and the center is at 4, -2. Okay, draw my box, draw my asymptotes, find c, go out in both directions. A squared plus b squared is equal to c squared, so that's 6.7. And my eccentricity is 1.5. And sweeping that out, and I get that. Okay, on your worksheet, make sure you find the length of the transverse axis. And this one happens to be x is positive. So it's horizontal, so the transverse axis is going to be 2a. The conjugate axis is the one that's going to be negative, so that'll be 2b. And the latus rectum, use the same formula that you used before, and if only if you're in honors. And the eccentricity, make sure you find all those terms. Okay, that's it. I try to keep this short, so I probably talked kind of fast, but it's a video, so you can stop it whenever you want. All right, thanks.